Good day to all our viewers. Thank you so much for taking your time to listen and watch this presentation, as this is an event for the Tri-Center Symposium located at the University of Central Oklahoma. As displayed on the screen, our fantastic team has covered the unknown locus responsible for bile salt resistance in E. coli. And this was inspired none other than the famous Dr. James Bidlack, who worked with Dr. Phil Silverman at the Oklahoma Medical Research Foundation, or known as the OMRF, and discovered a mutant strain of E. coli that is sensitive to bile salts. Bacteria. These small organisms gain so much attraction from the science committee because thanks to their ability, they become multi-drug resistant. Elucidation into these mechanisms of resistance would prove monumental in terms of medical cost and potential human lives saved, because it would be possible to develop techniques to limit infectious bacterial growth. For instance, efflux pumps. They play an important role in bacterium's ability to become multi-drug resistant. An increase in expression of these genes is coupled to a resistance of various substrates, such as bile salts, antibiotics, etc. Understanding the factors such as efflux pumps that allows multi-drug resistance in bacteria could contribute towards technologies needed to limit or inhibit unwanted bacterial growth. Wow! Look at them go! Corey and Regan, hard at work, prepping those petri dishes to make sure those bacterial colonies grow. And oh boy, does Dr. Bidlack sure seem happy that his students are hard at work. Materials and method. There's the thermocycler, which helps us with the process and method of PCRs, or polymerase chain reactions. Next, we have the electrophoresis gel, and last but not least, we have the Kodak gel imager, which is equipped with UV light. Okay, I guess some equipment was jealous. Look at them go, hard at work. Master student Ethan supervising undergrad students Victoria, Regan, and Corey as they make preparations for PCRs. Also hard at work, Zane and Corey making preparations for electrophoresis. Corey, fighting his desperation to go home, is persevering to make this project a success. Alright, viewers, the moment you've been waiting for. Show those results. The image to the left shows an amplification of an agarose gel. And from left to right, we have ladder 1, strains I, F, BW, 71, 72, and ladder 2. One sharp band was observed for each strain, indicating good amplification of DNA, presuming to contain genes of interest in each of the 5 strains. Comparing the BW 71 and 72 strains with the latter showed that these fragments were of the expected length, affirming that the bands were composed of the desired oligonucleotides. The bands from the I and F strains were much closer in length to the oligonucleotides isolated from the BW strain than those from the knockout strains. We believe that the I strain mutation may have resulted from substitution or short deletion or insertion. Each band was cut from the gel and sent to a commercial facility to be sequenced, but the DNA had degraded before arriving, rendering the genes indecipherable and necessitating further efforts. Isolating and decoding these genes will eventually enable future studies to increase the understanding of the mechanisms behind bile salt resistance and sensitivity.